Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
If you're not making yourself uncomfortable and you're not finding engineering problems that make you real uncomfortable once in a while, you're maybe not being as aggressive as you could be.
Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we're speaking with Ray Kampmeier, who is an electrical engineering consultant and product developer. Ray earned his EE degree from the University of Minnesota in 2013 and in 2015 founded his company, the Humble Transistor, or THT for short. There, he and his team provide electrical engineering and firmware development services spanning from proof of concept, prototyping, to designs for mass production. Ray, thank you so much for joining me today.
Thank you so much for having me on, Aaron.
You're welcome. Well, what made you decide to become an engineer?
I think I've got to decide how far back to go. I think like
all the way.
Like a lot of engineers, grew up playing with Legos and just kind of tinkering with materials around the house. My mom is an art teacher. She's a elementary and middle school art teacher and just a good educator. And she did a great job inspiring us to use our hands and to craft things and to be passionate about what we build. And on the other side of the family, my dad is a software developer, computer guy, so we got kind of a technical education coming up with that. And it wasn't until I was in high school that I met a couple professional electrical engineers, and I was really taken with the passion that just oozed out of them. You could tell that, when someone asked what they do, they were just smiling. They were so happy with their profession, and that kind of description of their job that they shared was infectious, and I got bit by the bug. I figured that sounds like a really fulfilling discipline, and then in addition to all that, we kind of grew up in this age of internet and computers, and it's so new in the history of humanity, and I think it's easy to get caught up in all that and just kind of take some of that stuff for granted. And I had these lingering questions, at least my whole life. And some people, I think, who might think like me are kind of like, I got to understand how this works. To use it, I kind of like got to understand how it works. And I always had this lingering question in the back of my mind of like, how does the internet work? How does this computer work? Like, what is this screen that I'm viewing a web browser on? How does that function? And so I had this appetite to kind of dig down and learn what a lot of electrical engineers before me, decades before me, they grew up with. So I did not grow up with an Atari or with a computer where you're dealing with just like such low levels of memory and things like that, and this resource constrained kind of like advent of computing. So for me, there was an appetite to kind of like go backwards and learn about what all of this electronics technology is about that is so ubiquitous in today's world.
Yeah, that's cool. I like your curiosity for, we're all standing on the shoulders of giants these days, and who were those shoulders? How were those shoulders built? That's cool.
Yeah, I want to reach down and ask those giants what their names are and get to know them a little bit.
Yeah, nice. So for the benefit of those listening who may still be students, not yet in the workforce, what are some specific things that they can do to be better prepared to contribute when they graduate? And specifically, like from an electrical engineering standpoint, it might be the same answer if it's mechanical engineering or chemical engineering or whatever, but I'd love to hear your thoughts, kind of specifically towards electrical engineering. What can they do to prepare themselves?
Great question. What jumps to mind is working on a personal project that they're passionate about. When you're just starting off, it's hard to find a paid work project, whether that be an internship or a co-op that you're really, really psyched about. If you have that already, that's great. You're, ahead of the game. But I would try to think of a way to fuse your discipline that you're interested in studying with something that you're really excited about. So for example, when I was in high school growing up, I knew I had some kind of passion for computers, and I decided I wanted to make a light show for my parents' basement that my friends and I could have dance parties with. And I had no idea what I was doing. I had no idea how to do this, but I knew that as long as I tried hard enough, I'd find some way to do it. I figured, hey, there's got to be a handful of different ways to pull this off as a DIY 18-year-old. And sure enough, through a lot of frustration and a lot of pain and mess ups, I got something to work, and my friends and myself were really impressed and really happy with the outcome. And so I think it's my advice is, don't get deterred by the frustrations of the learning curve, the self-educating process, and try to really feed yourself a reward at the end of it, and spend your time working and being frustrated on a project that's going to have a fun payout at the end of it.
The title of a book comes to mind, The Obstacle is the Way. And I think there's no substitute for just pushing yourself through the process of solving a hard problem in terms of education and being able to learn. And it's so easy, especially when we're learning something new, which is the case with students and new engineers. They're always learning something new. It's really easy to get discouraged or want to find a faster way to do this, which is natural, but it's that process, that painful process of not knowing how to do it and trying one thing and it didn't work, and try something else and it didn't work, and trying something else and asking people and reading on forums and, just figuring things out. That it's such a powerful process for engineers to learn, for anyone to learn, really.
Yeah, well said. I agree with that. I think it's hard, but you have to kind of develop an intuition for the right way, quote unquote, to do something. And that means something different for every individual and for their industry that they're working in. But if you start to think about the methods and the methodologies that you employ as your tools, and you're constantly sharpening those, and you say, hey, I know I could whip together this proof of concept in a day, but if I'm working on a production or design that's more production oriented, the right way, quote unquote, might be spending a few weeks to do it and make a really robust solution and to really vet the process that you're exploring.
Yeah, and I think an encouraging thought is that these are learnable skills. Some people might think that engineers have always been good at this stuff, and that's why they went into engineering. And there's probably some truth to that. Some of us probably are just naturally gifted in that area. I did grow up building with Legos and fixing my bike and things like that. So I think I had some natural mechanical proclivity. But I remember in college I had this job working in the physics demo center. We had all these cool physics experiments that we'd take to the physics classes for the professor to show the students. And there was a fair amount of building that went on. A lot of these demos were already built, but some of them were building brand new and some of them needed maintenance or whatever. And it was so exciting when my boss for the first time asked me to design one of these new demos. And so he gave me a few days to work on it. And I did a terrible, terrible job. It just didn't work at all. It was not something that a person who had experience designing mechanical systems would ever design. And I remember thinking at that time, geez, I'm a junior at this point in mechanical engineering. I'm supposed to know how to do all this stuff. What does this mean? Have I chosen the wrong path? But that wasn't the case at all. I just didn't have experience actually designing mechanical systems. So at this point, I have a lot more experience under my belt, and I could design something much quicker and much more effectively. But that's a skill that you learn over time as you figure out what works and what doesn't. There's another point. Maybe I'll wait to bring this one up until a little bit later in the conversation, because I think it's a point that you and I maybe have in common. let's see, what are a few of the most common paths that electrical engineers follow? Mechanical engineers, they might become a design engineer or focus on R&D or manufacturing. What are some common paths in industry that double E's have to choose from?
It's probably very similar to mechanical engineering. I know mechanical engineering can branch out in all those realms you just discussed and many more. That's what I love about electrical engineering. Same case, you can go so many routes. You could work for a power utilities company and deal with high voltage transfer from state to state and deal with real high voltage systems. You could do power systems for embedded electronics and smaller scale things. You could do power that's somewhere in the middle where you're doing like charging systems for electric vehicles. You can go a signal processing route that's more of applied math, and you could do things like try to scrub out noise from wind turbines on Doppler radar. So like you can use digital signal processing and advanced applied math and stuff for applications like that. Signal processing, DSP, that's everywhere. So when you're talking about rockets and aerospace and all that, even medical, there's DSP applied everywhere. So that's a great field to be in. You've got embedded electronics, like what I do, where you're building circuit boards for products that serve an individual purpose, like a product you'd find at Best Buy or buy on Amazon, like headphones, digital thermometers, even like computer monitors. These are all considered embedded electronics. You've got more general purpose electronics and high speed design. So guys that'll design server motherboards for really high speed data transfer for companies like Facebook or anybody who's running web servers. That exists in our computing products today, like laptops or home computing products. So I'm probably missing some other ones. Oh, we've got RF, we've got wireless. That's the dark arts of electrical engineering. That's the black magic side of things. And then, you can even go down like test and compliance. So here in the States, the FCC regulates the radio frequencies all around us and stuff. And so even within wireless technologies, there are these niche roles in the industry where you could help with certifying and making sure that products comply with government standards.
Well, speaking of black magic and the black box here, for me, Double E is entirely just a black box of magic. I don't really get how any of it works. I know I should, but I've never been good with electrical. And one of our customers likes to say, I'm not sparky. He says that about himself, but I think that's very applicable to me. I'm not sparky. Your company's named the Humble Transistor, which I think is just such a wonderful name. And it made me think that there's probably a story behind that. How did you come up with that name?
Well, I kind of liked the name because it reminded me of a medieval guild. It reminded me of like the Gilded Hen, or like, kind of like an English bar / medieval guild where you'd go to the Diligent Hammer or something. You'd go to this guild and you'd expect a high level of professionalism and reliability, and that the people that work there, this is a passion, this is a labor of love for them. And they're really working to refine their craft, and this is a place that they want to be, and they want to be working for these clients. And then the specific name itself, the Humble Transistor, similar to when we were talking about kind of why I was interested in getting into electronics and wanting to work backwards towards the history of like how we've come to a place we are. I wanted to kind of draw out this idea of we design embedded electronics and we're tied into the real world. So we're kind of at this junction between the mechanical space where we're dealing with physics and chemistry in our chips and in our components, and the world of software, which is much more abstract and kind of floating above society. It's a little bit harder to grasp and understand how that ties into the real world. And so in addition to that, I also wanted to emphasize and kind of hold ourselves honest of remembering how much you can do with this elemental building block. This transistor is the core component that's spurred this modern information communication age, and it still is the main shebang. We talk about the chip shortage and what's going on with Taiwan semiconductors. It's all about packing as many transistors as you can into a chip, and these transistors, you can just do so much with them. So in our designs, we try to make these really cost-effective, production-ready electronics designs, and like not get weighed down with the bloat of like highly integrated, really complex, really expensive chips. And so we're not taking the easy route. We're not taking the handheld, like off-the-shelf, pre-made solutions and just putting 3 or 4 parts together. We're getting down to the nitty-gritty. We're getting down to the lowest level that we work with, and that's the transistor.
Very cool. As I thought about the name, the Humble Transistor, it got me thinking to myself, do I really know what a transistor is? And the answer is no, not really. I know it has something to do with like processing a signal or amplifying a signal or transferring a signal, but I don't really know what a transistor does. I was watching the Apple event the other day, and they talked about their A16 chip having like some stupid number of transistors in it, 10 billion or 4 trillion or some very large number. What is a transistor? How does it work? What does it do?
Yep, I love it. Apple gives us the marketing lingo. They try to wow us with the millions and the billions, but yet they're not explaining the relevance of this. So the transistor, I guess, it helps to understand why it was ever made in the first place. And so it started with communications and with phone lines. So long distance calls, when long distance calls were just starting out, there were these telephone exchanges that were like one city block by one city block. These massive buildings. There was one in every prominent city, and these had a bunch of like electromechanical relays almost that were connecting different calls and routing calls throughout the country. And Americans had this huge appetite. This is global as well, but America pioneered a lot of this, and Bell Labs had a lot to do with this. But there's this huge appetite for being able to connect with people across the country. We take that for granted. Yeah, I'm looking at you across the video call right now, but imagine for the first time you're able to call someone in Cincinnati and say, "Hey, stranger, like, how's it going? What's it like over there?" Or you're able to call someone from a magazine you love and you get to talk to one of the editors in person. And so there's this huge pressure, like human pressure, to pioneer this technology. And the engineers that are supporting this at Bell Labs and a bunch of other telecommunications companies, they're just hustling to keep up. And they're like, it's so fascinating. Like every decade, it's a whole new set of technology that they're using to try to keep up with this demand. And at first, they were employing telephone operators, human beings, and they quickly realized this isn't scalable. With the trajectory that this is going, we don't have enough human beings in the world to support this network. We need to automate this. And so they use what they know, and they at the time, there were these really sophisticated electromechanical relays, and I think Germany was sourcing some really good ones at the time. And so these would take minutes and minutes to like relay your calls, and they were prone to burning out, and they would require a huge building and they'd kick out a lot of heat. And so Bell Labs pioneered a solid state switch. So rather than an electromechanical switch, they created the transistor. And so at the simplest form, you could think of a transistor as a three-port valve. You've got your input and your output on this valve. And then the control is also an electrical signal. So when you look at the light switch in your house, you could think of that as a quote-unquote 3-port device where you've got your input, your house's electricity, 120 volt, and then where the light bulb connects. And then the third port, the third connection is your finger, and you're mechanically toggling that. And so the breakthrough of the transistor is there's no mechanical control. It's an electrical control. And so now the input, the output, and the control signal on this valve, they're all within the same domain, the domain of the electron. And what that allows us to do is to pack millions and billions of these on the same chip and have them all routed to one another. And so now what started as a simple electromechanical manual control light switch on your wall, we've got kind of what's like neurons in the brain. We've got these little valves that are like synapses that are talking to one another, controlling one another. And now we've got these vastly complex valve networks that are scooting electrons around in novel ways and performing the tasks that we've kind of come to accept, like doing things like presenting what our monitor shows to us, routing our data through the internet, and allowing our phones to function.
That was a wonderful description. I don't think I've ever heard anyone put it so succinctly or just descriptively. That was great. Thank you so much.
Thank you.
So the transistor, then, you said that it functions entirely in the electrons domain. Is that to say that you can't see a transistor under a microscope? There's no like mechanical structure necessarily. Well, it has to be some kind of mechanical structure, but
there is mechanical structure, and you can see them. You could even make them in your garage. There's some great electrical engineers out there that are posting YouTube videos of how to make a transistor, just like they did back in the 60s at Bell Labs and stuff. And but in today's age, you hear things like 3 nanometer chip technology, and you hear these nanometer scales that AMD are making computer processors with, and Apple is making their custom silicon in these scales. And at that point, it's so small that you would need
electron microscope.
You would need an electron microscope, right? I'm trying to think of what industries even have that level of imaging. But at its core, it's really cool. It's like electrical engineering and technology as we know it is pioneered by mathematicians. They create the language in which we can build technology. They create this system in which we can even like discover new technology. Physicists and chemists. And so when you study semiconductors and this is a whole nother realm of electrical engineering, when you ask which ways you can go, there's people who purely just design silicon for chips and deal with creating these new processes. We can pack more into these chips. And so at its core, it's they start with bare silicon. Silicon is a crystal. So when you have people out there that are kind of mocking these like new age energy healers and people who use crystals to like levitate and do things like that, I always get a laugh out of remembering that like our phones are running on these magic crystals that like let us communicate with people around the world. And
they all started, yeah.
It's a more scientific approach to the magic crystals, but they use, it's a type of like holography. Actually, it might not technically be holography, but they use these really, really high-end masks that you're projecting light and basically etching away layers of the silicon. And then on top of that, there's a whole bunch of processes that I'm not qualified to speak on, but you're essentially growing like oxide insulation layers. And so you're growing these little nanostructures. It's kind of like nanotechnology. You're making these tiny mechanical structures, but the term solid state implies there's no moving parts. So other than the flow of electrons within these molecules, there's no physical moving parts. So there's no wear and tear.
Wow, that's very cool. I've heard that in semiconductor, all of the chips that are made with the same process, and what differentiates whether a chip is, I don't know if this is even quite the correct terminology, but like an i7 versus an i9 Intel chip, is how well that process worked on the chip. They try to make them all the exact same, but because of manufacturing processes, variations in the manufacturing process, they don't all come out the same. So some of them end up being faster than others, and those get classified as i9 or i7 or whatever they are, and sold at different price points. Is that accurate?
That is very accurate. It's a unique approach to salvaging yield. It's so in manufacturing, whether it's you're making mechanical products or electrical products, you've got some percentage that fails your quality control checks. And so the processor manufacturers in today's age, whether that's Intel or AMD, they have a unique approach to it. They say, it's ineffective for us to try to dial in our process so that we're getting 99.9% yield. What we're going to do is we're going to design and architect our transistor kind of little city within the chip. And we're going to make it in a way so that if we detect that certain sectors or certain subsystems are not functioning because this really, really detailed, super microscopic process, it's error prone, we're going to just disable those and sell it as a lesser tiered product.
That's brilliant. Great business strategy.
It's a good business strategy. And then one quick thing I want to add related to the yield is I heard just in the industry from a friend who'd worked for a big silicon manufacturer is there'll be things like you'll get when you're working there, you'll get notices of like, hey, we want to warn people that a certain deodorant or perfume or something is affecting yield. And so just chemical traces going through a clean room jumpsuit in just one small step of this whole process can significantly throw off yield that you're going to have to ask your employees to change up their personal hygiene.
That is amazing. One of the team members here at Pipeline worked at Intel for some time, and he was telling us stories about troubleshooting they had, and their yield had fallen off. They couldn't figure out why, and they spent, can't remember how long it was. It was maybe a week or something, and the line was down for this entire period, which is a huge loss in revenue. And they were getting like traces of I think it was copper, just where they weren't supposed to have any, and they couldn't figure it out. And finally, they found out that there was a mechanical connection somewhere, and a copper fitting had been used where it was supposed to be a different material, and just the tiny trace molecules of copper that got scraped off into the air when that fitting was connected or disconnected was enough to throw off the balance of this entire line and decimate their yield, which was just mind-blowing to me that such a small thing could have such a huge impact.
Aaron, it reminds me of tin whiskers. Have you encountered that at all? It's kind of related to aerospace and metals used in products. There's a phenomena. It's a type of like metal migration. So there's a handful of different forms of this. And I think it's probably similar to this, where like tiny copper flakes can like catalyze metals actually growing out in like a plant in a certain direction.
Fascinating.
The tin whiskers, it happens more in zero gravity. So when you're working on satellites or you're working on aerospace projects, like what NASA would be looking at, they realized that metals and certain alloys would grow what look like whiskers, and they're just like these perfect, almost like a crystal, and they're like these perfect hairs. They look like a cat's whisker, and it would short out electronics. You'd have satellites going out of commission or losing sensors stuff, and it's nutty. Yeah, once it's like the further you learn about some of these industries, the more like mysteries just crop up.
Which is why the world needs engineers like us to solve these little problems. Yeah. Well, I'll take just a very short break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. We're speaking with Ray Kampmeier today. And Ray, earlier I mentioned that I was going to save a question for a little bit later. So this is the point in the conversation where I'm going to bring this back. You, I think, if I got the math right here, only worked for a few years after graduating before starting your company. How did you decide to hang your shingle and start your own business after only a few years?
Well, Aaron, when I was in school, I was always really self-motivated and self-driven. When I was in high school, I remember I was taking a computer science class, and my teacher wasn't a big fan of me because I was jumping ahead and trying to shoot forward past the curriculum and kind of like take what I was learning and really try to run with it. So I was hot to trot. I was kind of chomping at the bit, ready to break out through the gates. And when I was in college, I was a hard worker when it came to the schooling, but I was really a hard worker when it came to passion projects and outside projects. And so I was working with some artists in Minneapolis and working on art installations. And somehow that led me to get into product development. So those were kind of like the first products I was working on, were these one-offs that were up and running for a few months, and a lot of animatronics and puppetry and stuff, and animatronic theater. After that, I got linked up with this company called Logic Product Development in Minneapolis, and that was like heaven for me. That was like Willy Wonka's factory. It had mechanical engineering, industrial design, electrical engineering, a whole staff of project managers. They had a manufacturing line where they were doing medical, military, aerospace product manufacturing. And so it was basically like full turnkey design services and manufacturing. And for a guy like me, it was like huge appetite to learn about the industry, and everything and everybody who I needed to talk to was right there. And so that was really exciting. And like to this day, this is a college internship, and I just absorbed so much, and I'm so happy for an opportunity like that. So you had talked a little bit about like what people can do who are in school and still thinking about this. It escaped me at the time, but you got to get an internship. You got to get a co-op. You got to talk to somebody, even if it's unpaid. Get out there, get into an industry that you're excited about and start to try to help them out in the best way you can. I was entirely ineffective for this company. I was doing a lot of like, hands-on, kind of like a lot of manual testing and technician work and stuff like that. But I was able to ask really smart engineers questions every single day and to just pick their brain. I felt like I was paying my dues by doing the grunt work, and I in turn would ask a lot of questions and try to just soak up as much as I could. And so after that, when I had graduated, I moved to California to join a small startup company as a second employee at a company called Punch Through Design. They do similar work to what I do here. They had a lot of emphasis on Bluetooth and like IoT products, and helped grow that company a little bit. We released a product called the Light Blue Bean. That was an internal product that helped people fast track making IoT products. It was like a little Arduino development kit that runs on a tiny coin cell battery. You can program it from your phone, so you could be kicked back on your couch and prototyping your next great invention, all from your phone. And then in addition to doing those, we were doing a lot of client projects. So we were working with a million different startups, not a million, but dozens of startups in the Bay Area, and I'm learning all these pain points. So I had already gotten some product development chops, or at least been exposed to what's out there and best practices, and how to do design verification and how to certify things at an FCC lab. And I just learned kind of the rigor of what's required for medical, military, industrial consumer products. And now I was in the Bay Area, able to apply that. And so it was very fast paced. So you mentioned, you're right. I started this business maybe 3 years out of college, and but I feel really grateful it felt like I had worked for, dozens of companies, and just getting an inside look at all these startups who are trusting us to come in and implement these best engineering practices for them. So towards the end of that time at PunchThrough, I figured, hey, I'm ready to do this for myself. Like, I know how I want to do this. And not to say that PunchThrough is bad at doing the product development. I just knew that I have a way that I want to do this. I want to put it all together now. I'm done. I'm done kind of like waiting and kind of like paying my dues, like waiting for my time to put it into motion. And that's when I started the Humble Transistor, and been enjoying it ever since. And like I said, it's like, as long as you're self-driven and you're willing to learn and refine your own methodologies every single day, and to try to do your job better every single day, it's like, just do it. Just take the leap of faith, right? Like, I feel like I'm still learning every day here. So I'm pretty happy with that decision.
Well, listening to you talk, it sounds like you had a much more sure-footed beginning than I did when I started Pipeline. I got laid off. That's how I started Pipeline. And I'd only been working for about 3 years professionally. I had a couple of internships before that. By the way, I agree 100% with what you were saying about internships. The reason I got my first job was because I had an internship and already knew some very, basic skills. Anyway, I got laid off. It was during the recession, and I started Pipeline because I didn't feel like going back to work for another company. But I definitely had a lot of imposter syndrome. I did not have the luxury of having worked for, a plethora of different companies when I started. And there were a lot of things I just didn't know how to do. That's probably maybe one reason why I'm so bad at electrical, because I didn't do any electrical. And when I went off on my own, that was definitely not my strong suit. So I didn't pursue anything even closely related to electrical. Anyway, we talked earlier about what can engineers do to prepare themselves. I feel like I'm really good at what I am good at now, which is mechanical design. I'm not the strongest analytical engineer for sure, but I'm really good when it comes to mechanical design engineering. And I think the reason I'm so good at it is because I didn't have many resources to turn to when I started my company. And so I spent a lot of extra time on my own just trying to figure things out, whether it was some research on the internet or just trying something and it didn't work. So trying something else and reading through SolidWorks forums and learning the CAD tools and talking with vendors and understanding what material is going to work and what kind of bend radius certain aluminums can accept for sheet metal and all these different things. And that was, talk about trial by fire. That was definitely it. And I learned, so much through that experience of just trudging through the difficulty every day. But it was also fun because I love doing this stuff. So I don't want to make it sound like it was just this arduous ordeal that I hated. That wasn't the case at all. It was just a lot of work, but a lot of fun work.
Well, it shows, Aaron. Pipeline is so polished and professional. And to hear you say that, I'm like, okay, well, you clearly had a lot of success in the method that you employed there.
Oh, thank you. I appreciate you saying that. Yeah. I think that there is something too that you mentioned, how you were kind of done putting in your dues and you were ready to do it your way. I think that's a hallmark of entrepreneurs. We want to do things our way. And I definitely have strong opinions about how things should be done and the right processes and things like that. So I've always thought engineers make great business owners because we're very process oriented and I don't know, an engineer entrepreneur, I think is a powerful combination.
Yeah, I agree. And I'm glad to hear you share the same sentiment about, doing it our way. And I don't mean that as like a control freak, kind of like controlling attitude, but it's like, I think it's important to do your work to your own standards and to make sure your standards meet or exceed the client's. That's one of the big ones. And when I said I was ready, it was like I knew to what level I wanted to perform and I wanted to do right by the clients, and I kind of knew what was required to, like, at the end of the day, feel like I contributed and created something of value. Because technology is so confusing. You could work all day for years and years and years, and at the end of it all, the overall project was a flop, or something happened, or you were just off the mark. You were working towards the wrong direction, and so I felt like, hey, I'd accumulated some knowledge, and I could use it in a really potent way, and I could do right by the clients and get them the most bang for their buck.
Yeah. Yep. Fantastic. Let's see. I think I've got a few more questions to go through, and then we'll wrap things up. Can you think of a time when you got stuck on a technical problem and you just didn't know how to solve it? It was beyond your means at that time. And what did you do to find the solution, and what did you learn from that experience?
Good question. Sounds like that's like a good job interview question. Well, I think one good lesson to remember for especially electrical engineers, I know I feel like when you're at engineering school, you kind of get these stereotypes for all the engineering disciplines. You got the civil engineers who maybe know how to party a little bit more, and you got the mechanical engineers who are a little more well-rounded. You got some better people skills, and I don't mean to diss us, but the electrical engineers, like, we're known for our math skills. I don't think we're particularly the most personable, like, socialites.
I wouldn't say that. I always thought of electrical engineers as like, well, chemical and electrical felt like the top tier engineers. Those were the guys who were really, really smart.
Okay.
And then there was mechanical, and then there was civil. I'll throw the civil under the rug just like you did.
Okay. No, and I wasn't trying to bash the civil. I think there's something what I'm getting at, maybe it'll make more sense as I continue this thought, but I was going to say, some of the most challenging problems I've faced were ones where I realized I've got my head in the sand. I've dug into a problem so deep where I've kind of like lost touch with people in my network who could help. It could be as simple as reaching out for help and just writing a detailed forum post or calling up that old coworker of yours who had worked in a related field and maybe asking them. And so, it could be as easy as me writing you, Aaron, and saying, Aaron, I've got this mechanical automation problem, and I don't know if it's big enough to be a project that you're interested in, but, like, would you mind giving me some, feedback on this? And so, for example, one of those times it happened with wireless certifications. We failed a wireless certification, and you're at the testing lab and you're just hemorrhaging money. You're having to pay per day. So you're like, I got to solve this in a matter of hours, because I can't be paying for every single day that we can't figure out this bug. And so in that case, I was really happy. This was early on in my career. I was happy to be forced into a position where I realized, okay, even though I fancy myself as a generalist, I can't solve this. This is over my head. This is a very niche domain, and I can't solve this at least in a matter of hours. And so it was a reminder to me that as an engineer, you really need to foster a good network of people in these different domains that you can count on, you can lean on, and you can in turn reciprocate and provide this domain expertise to guide people when they're in a pinch. Because if you're not making yourself uncomfortable and you're not finding engineering problems that make you real uncomfortable once in a while, you're maybe not being as aggressive as you could be.
Great quote. I love that. All right. Well, let's see. I'll just do maybe one more question here, then we'll wrap it up. What tool do you think should exist that currently does not exist that would help engineers do their jobs better? It's
a good question. One area of our job that I think is pretty uniform across a lot of engineers, a lot of computer scientists, is searching for information on the internet. And that could be through academic literature. You can use, tools to find white papers and academic papers. But it's hard to get around avoiding Google. We all need to Google things, and Google is this huge wealth of information. And it occurred to me recently that I just might not be brushed up or educated enough on like the latest Google algorithms or the way to format words, search queries on there. And so it made me think that whether that be at a typical 4-year college academic environment, whether they add a class or something like that of like the art of teaching yourself, right? Like the art of finding out answers to the problems or the questions that you have. Back in the day when we were growing up, we all went to the library and were taught about the Dewey Decimal System and how to interface with a librarian and things like that. And so, it's not as hands-on. It's not like a very direct engineering specific tool, but I think something that would help a lot of us who are constantly seeking answers every day in our work. I think maybe just like getting a refresher on these are the different tools. This is how Google has changed. Like this all was spurred on by, I had this moment where I just realized, like, does the order of words affect my search query? Does Google weigh words when I put a question mark? Does it behave differently and try to infer that this is more of a question? And so, yeah, that's kind of what I think. What about you? Do you see something as being an obvious upgrade for our engineering tools?
I always go to communication. I think as engineers, we are technically trained very well at school, but there isn't a single class in college about how to communicate with others. And that is as big, if not bigger, part of our jobs as engineers than the technical side of things, is just knowing how to talk with other people. I just interviewed Andre Sotomayor, who's a principal engineer at Johnson & Johnson, and he has this great quote. He says, "It doesn't matter if you're the smartest person in the room if everyone thinks you're a jackass." And it's so true. So I think better communication tools, and I admit I don't know exactly what that means, but better ways for people to talk with each other and communicate, a thought from one brain to another brain.
I do it by talking really fast and just throwing a lot of things out there.
They'll pick up on the most important parts. Sure. Yeah. Our engineering manager, Michael, likes to say that the meaning of how does he put it? The meaning of communication is the result you get. In other words, if you tell a person something, but you get a result that you weren't looking for, that's on you because you had poor communication. So the meaning of communication is the result that you get. I like that. Yeah. All right. Well, Ray, thank you so much for spending this time with me today, taking some time out of your busy schedule to share some wisdom and insight with all of the listeners. Anything else that you think we should talk about that we haven't hit on yet?
I just want to say it one more time, Aaron, thanks for having me on. And I'm not trying to just pump up Pipeline just because you had me on here. I'm a huge fan, and I've followed you for, I think, a couple of years now.
Oh, wow.
I am so impressed with the marketing material that you put out and just like I said, the level of polish in your company's work. And it speaks for itself. You talk about a picture, speaking louder than 1,000 words. You got millions of words packed into this picture, and it's just, I'm excited to be working with you guys more in the future. And I'm just impressed. I think you mentioned the power of an engineering driven company, and I think Pipeline clearly is that.
Wow. Thank you so much for saying that, Ray. I'll send you that check we talked about later.
Oh, thanks. Yeah. Thanks, Chichi.
That's very, very kind of you. Thank you. All right. Well, this was great, Ray. And thanks again for being on the show.
Thanks for having me, Aaron.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.